Okay, this is part 2 of this chapter 12, Perspectives on Environmental Policy. And this second section is going to be on a couple of more incentive-based solutions um, for pollution control. And this first one is going to be on a carbon tax. And here is the carbon tax here. And it sets a tax, a PAGU tax. Remember, and this is from chapter 4, that a PAGU tax is a specific tax on a negative externality. And the idea is to um, uh, have the person pay for the privilege of being a polluter, giving that negative externality, and and is not necessarily designed to be a revenue generating device. It is a way to get the polluter, in this case, to pay for the internalized externality and bear the full consequences of his or her behavior. Now, it's typically drawn as a shift of the supply curve. So this is typically on the supplier, who then may pass it on to the buyer. And they would pass it on to the buyer to the extent that they can get away with it. If the demand curve is more inelastic or steeper, they can pass more of that cost on to the buyer. Less elastic, less ability to do so. Now this graph here also has a tax on the buyer, and in that way that would shift the tax that would shift the demand curve to the left, and so let's say by $1, and so there would be a shift in the left, and so less gallons of gasoline consumed. So if you remember from previous chapters, when people emit a negative externality, they're looking at their own private costs and not taking into consideration what they are doing to their neighbor. So there's more that is emitted. If you put a tax, then the idea is you will emit less you will emit less gallons of gasoline because you're being taxed for the privilege. It would be the same idea as a cigarette tax, or maybe even an alcohol tax. But again, and to the extent that the demand curve is inelastic, that might mean that you're going to get less reduction, and the seller is able to pass this on more to the buyer. So the idea of the carbon tax is you go ahead and emit, but then you'll have to pay for the tax as you'll have to pay the tax as a result. Okay, so another way is called tradable emissions, and your book has an example of the two-firm pollution model. So here we have the picture that you have in your figure 12-1. Let's see if that's the same thing as in the 5th edition. I'm almost positive that is page 295. And actually, it would be page 293 in the 5th edition, and yep, exactly the same picture. So what's going on here? So under equal emissions, that would be firm 1 and firm 2, both doing the total amount of emissions, and you can see down there at the bottom is the total regulated quantity of emissions. Firm 1 gets A plus B, while firm 2 gets D, E, and F. And so firm 2 is more efficient than firm 1. Maybe firm 2 has better technology and pollutes or produces at a cleaner emission rate than firm 1 does. So under efficiency, firm 1 would get A plus B plus C plus D, while firm 2 gets E plus F. So And so that would take advantage. So firm 2 doesn't necessarily need to emit as much to be able to produce what it needs to, but firm 1 does. So firm 1 would get more, shall we say, consumer surplus relative to firm 2. The question is how to do this. Now, going to efficiency, there's a net societal gain of C, but achieving this with government control would involve information and enforcement. So government control is going to, you're going to have to measure what that extra C is, and government would need to enforce that firm 1 and firm 2 are adhering to the new goal, if they were to do a command and control type of a system. Now, tradable emissions, the idea is that both firms will get a certain amount of permits give for the right to pollute. Let's say they get an equal amount of permits, although according to your book, it really doesn't matter. If one firm is more efficient than the other, then that one firm can sell the permits to the other firm, so that they can go ahead and produce, and because they're not quite as efficient at it. So in this case, firm 2 will sell permits to firm 1, so that firm 1 will receive C plus D and will reach the efficient level. And so in essence, there will be a price on the ability to pollute on the part of firm 1 that firm 1 is willing to pay for, because it would be more expensive to curb the pollution than to buy the permit. Whereas for firm 2, they already have the technology, and so for them, they can do it a lot better than firm 1 can, and so they'll sell their rights to pollute to firm 1. Society gets still the total, the target regulated quantity of pollution. It's just that now we're letting the market set what is the efficient standard as opposed to the government. And we economists strongly believe that the market is a much better judge as to what is efficient based upon willingness to pay than a government target. So according to your book, this allows flexibility and creativity. There are various different means of achieving these permissible emissions levels, like conservation technology, alternative energy sources, lower sulfur coal, or the purchase of permits. It allocates emissions rights to those who value them the most. The ones with increased technology can sell those permits to firms who do not have the more efficient technology. And it provides incentives for reductions beyond the regulation level. And even firm 1 would have the incentive to reduce its emissions, because otherwise it would have to buy permits in order to achieve its target already. Okay, so now we have tradable emissions rights in practice, and there are various terms that in how tradable emissions is typically done. And we have banking, that occurs when a firm achieves emissions levels below an established standard, and so is allowed to save or bank pollution permits for future sale or use, like a savings account. Bubble provisions effectively allow trading within the firm or area by aggregating all sources of a specific pollutant within a bubble and looking only at the total amount of pollution released from the bubble. Offsets allow increased emissions in an area that has not met environmental quality standards if they are offset by even larger reductions elsewhere in the same facility or in another facility. In other words, and this has kind of entered the public conversation, if I pollute in one area, I can offset by that pollution by engaging in good environmental stewardship in another area. So if I drive a car if I plant trees, that kind of offsets the carbon damage I'm doing by driving the car. Finally, there is netting, and netting allows existing firms to expand their operations and avoid the relatively strict emission standards for new facilities, provided that their net increase in emissions falls below a set level. So cap and trade, your book has something about cap and trade. So here we set a target amount. So so your book sets a limit on releases of particular pollutants and allows allowances for portions of that quantity among existing firms that can then trade them on the open market. So cap and trade is a version of tradable emissions. You set a cap and then you trade amongst the firms in order to still achieve that cap, but some firms are better able to be efficient than others. So examples of cap and trade in practice. There is the let's see, the EU emissions trading system. Where is that in your commenced in 2005, largest permit trading system in the world, and it covers CO2 and nitrous oxide. Targets a 20% reduction in greenhouse gas emissions. So member states are able to trade amongst themselves to achieve the reduction. Acid rain reductions in the United States. So the U.S. is trading rights. Companies are trading rights to pollute or produce one ton of sulfur oxide emissions, and so you're trading for that right to pollute as well. And let's see, Australia has a salt pollution credit trading program, and U.S. EPA oversees a credit trading program for phosphorus, nitrogen, and sediment releases into waterways. As part of the National Pollutant Discharge Elimination System. So all of these programs are all about setting a cap and then allowing countries or companies to trade amongst themselves from most efficient to least efficient, and setting a market for those permissions to pollute, as it were. I oftentimes say it's like playing cards that countries are traded amongst themselves. One of the criticisms is that the cap oftentimes is set too low, and the cap really needs to be set at a higher rate in order to truly have an impact upon air pollution. Alrighty, this is this is part 2, and I'm going to end things right here.